What is pesticide drift? Pesticide drift is the unintentional airborne movement of pesticides outside of the target area. It occurs whenever pesticides leave the intended target site during or soon after an application. The goal of this video is to provide the viewer a better understanding of what pesticide drift is and to better understand how to mitigate drift. Why is drift a problem? Drift is a problem because it can result in inadequate pest control and wasted pesticides. It can cause damage to off-target sites and neighboring crops. With that can come environmental concerns and negative public perception. We live in a litigious society. Friendly, happy neighbors may not be tolerant of pesticide damage to their crops or property. Pesticide applicators may have to pay for damages or be forced to pay fines if the Louisiana Department of Agriculture and Forestry's Pesticide Division becomes involved. Drift can have a huge impact on your time and your money.
So many people have moved to the country thinking that they're going to be part of the community, and what happens is that they end up finding that there's a little drift and they're aggravated, and so we catch the brunt of it, and we have to be more careful, but certainly hope that the neighbors would be understanding.
In order to effectively manage spray drift, the pesticide applicator needs to understand the basic causes of drift. These include weather and ground conditions, equipment setup, and even the applicator's attitude when applying pesticides. Pesticides are an important and effective tool in pest management when they are applied safely and effectively. It is important to understand the major types of pesticide drift, and there are two: vapor drift and particle drift. In this video, we will focus more on particle drift, but let's first briefly discuss vapor drift. Vapor drift occurs when a pesticide changes to a gas and moves from the application site. Vapor drift occurs more when the air temperatures are high and the humidity is low. The active ingredient for some pesticides can evaporate or volatilize during application, or even several hours afterwards. Some active ingredients have more potential to volatilize than others. One step to avoid vapor drift is to follow label directions carefully. Read the pesticide label for specific procedures and warnings, such as maximum air temperatures or soil incorporation requirements, to reduce the potential for vapor drift. An example of a label warning statement would be, avoid application when temperatures may exceed 85 degrees Fahrenheit during or for 24 hours following the application. Now let's discuss particle drift. Particle drift is the movement of spray droplets produced at the time of application. This is when most pesticide drift occurs. During an application, smaller droplets are more likely to drift than larger droplets. There are many factors that can influence droplet size, such as pesticide formulation, the nozzle type, sprayer pressure, and weather conditions. It is the applicator's responsibility to consider all factors that impact drift from a specific application before deciding whether to spray or not to spray. Prior to any pesticide application, it is essential to evaluate the site. Seek out and document potential problems before you make the application. Identify areas such as sensitive crops and environmental sites, houses, schools, and other inhabited areas. Applicators must know the direction of the prevailing winds and what lies downwind. During any application, some droplets may be carried downwind from the application site. There are many things that you can control as an applicator to mitigate spray drift, but you can't control the weather. However, you can decide when the weather conditions are best for planned applications. Here's how weather can affect the potential of spray drift. Weather conditions that impact spray drift are wind, temperature, humidity, and temperature inversions. Pesticide applicators can get into trouble with spray drift if rushed for time due to an approaching inclement weather or lack of daylight. You should check local weather regularly to assist in making application decisions. You can get your weather information from local weather TV and radio stations or weather apps. Keep in mind that weather information from media sources can be miles from the application site. We recommend using an on-site weather tool or a portable weather station to collect real-time weather data. Local weather conditions can differ due to unique conditions such as vegetation type or the presence of a nearby large body of water. Be sure to always record weather conditions during an application. Let's look at weather factors that may impact your application. The most common cause of spray drift is wind. Pay attention to both wind speed and direction. Refer to the pesticide label for application wind speed restrictions. If the pesticide label is not specific, it is recommended that applications be made when wind speeds are between 3 and 10 miles per hour. Wind speeds of less than 3 miles per hour aren't necessarily ideal because conditions are favorable for temperature inversions. Air temperature and humidity both affect vapor drift and particle drift. As air temperature gets higher, water from some pesticide spray mixtures can evaporate more rapidly from spray droplets. Notice how conditions of high relative humidity and low temperatures affect the spray droplet. Similar to conditions on a cool but humid morning, the droplet maintains its size. Then if the weather conditions are hot and dry, the pesticide mixture tends to evaporate more quickly as the droplet falls. The droplet then shrinks in size. It falls slower, allowing more drift potential. Another factor that can cause off-target movement of pesticides is performing applications during a temperature inversion. Before explaining temperature inversions, we need to understand normal conditions. Under normal conditions, during daylight hours, the warmest air is near the Earth's surface, and the temperature decreases with increasing altitude. The sun warms the ground and the crop canopy. This in turn warms the air that touches it. The warm air then rises and is replaced with cooler air from above, causing a mixing action of the atmosphere. Winds that are generated often blow from a fairly consistent direction. During a temperature inversion, these normal conditions are reversed. Air temperature increases with increasing altitude. Inversions are caused when the ground cools from the loss of daytime heat. Typically, temperature inversions last from late afternoon hours until several hours after sunrise. This means that there is warmer, lighter air above the cooler, heavier layer of air next to the ground. When there is no wind present, these two air masses will not mix, resulting in a temperature inversion. A good visual of a temperature inversion is morning fog. Here, a smoke bomb shows inversion conditions. Temperature inversions can occur at any height and at any time of the day. They can occur around bodies of water and in low-lying areas. Vegetation around a field can also impact how strong temperature inversions are in that area. The major problem with inversions is that applicators perceive little air movement and assume it's a good time to spray. Really, it is one of the worst times to spray. Be alert to the possibility of an inversion. Temperature inversions can result in long-distance pesticide drift. If a pesticide application is made during a temperature inversion, small pesticide droplets can remain suspended above the sprayed area for a period of time. Under normal conditions, these smaller droplets would rise and dissipate into the higher atmosphere. Instead, in an inversion layer, they remain suspended over the field. Later, when the wind picks up, these droplets can move off target. In some parts of the country, significant temperature inversions are an almost everyday occurrence. Know your application area well and make decisions that will minimize spray drift. A rule of thumb to help determine when a temperature inversion has lifted is when the temperature has increased 3 degrees Fahrenheit from the morning low. Then, if the temperature decreases from the afternoon high more than 3 degrees Fahrenheit, it indicates potential formulation of another temperature inversion.
So the biggest thing that you've got to think about, they set up in the afternoon. So when these farmers are spraying late in the afternoon, there's a chance that that pesticide could catch in a temperature inversion and move off target. So that's important.
So far, we have considered the two types of pesticide drift, vapor and particle drift. And we have looked closely at the weather factors that can cause unwanted drift. Factors such as wind, wind speed, wind direction, and relative humidity. Don't forget, make sure you record the weather conditions at the beginning and the end of your applications. This is part of your responsibility when applying pesticides. Factors such as weather, wind speed, wind direction, relative humidity, and temperature inversion are not under our control. But by being aware of the environmental conditions present before and during pesticide applications, pesticide drift can be mitigated. Now let's discuss a few practical ways to avoid unwanted pesticide drift that are within the applicator's control. Proper equipment setup, operation, and maintenance is critical in drift mitigation. Equipment and application factors such as equipment speed, boom height, or nozzle type, size, and pressure are critical in mitigating drift. Increased operating speeds can cause the spray to be diverted back into wind currents and vortexes behind the sprayer. This can trap small droplets and can contribute to drift. Applicators should follow speed recommendations and then product labels, nozzle catalogs, and equipment manuals. The distance between the nozzle and the target can contribute to pesticide drift. Boom height directly affects how long spray droplets stay airborne. As the distance between the nozzle and the target area increases, the greater impact wind can have on drift potential. Wind can carry smaller droplets off target. Drift potential is reduced when the boom is closer to the target. Of course, boom height can dramatically affect the spray pattern and coverage. Follow manufacturer guidelines for the spray tips and nozzle spacing you plan to use.
Most nozzles are typically rated for about 18 to 24 inches above target. Oftentimes I'll see one of these high boys where the boom is 12 feet tall or 8 feet tall in the air. Secondly is speed, ground speed. If your target's right and you're calibrated properly, you can go fast, ground speed. But when you add the combination of the high boom as well as the fast ground speed, that's just a nature, almost like it's a wind shear, like you see with the airplane, as far as moving off target.
Proper nozzle selection is critical to mitigating drift and can improve droplet consistency. Nozzle selection is often based upon droplet size. Larger droplets are less likely to drift than smaller droplets and are less affected by wind. Nozzles determine the uniformity of the application, both across the width of that nozzle and across the width of the boom. As an applicator, you want the pesticide evenly distributed across the field. Nozzles are crucial to get max coverage for control. Better coverage is usually equated with a smaller droplet, although this can increase the chance for drift.
For something that's systemic, that it actually has to be absorbed by the plant and moved to the plant, you need a bigger orifice. Things that are contact, more of a smaller orifice, so more finer droplet. Problem is, the finer the droplet, the more likely it is to move. Think about a feather. If I throw a feather in the air, it's going to move further. If I throw a rock in there, it's not going to move as far. That's the best way that I like to think about it.
Factors such as wind, humidity, temperature can create a situation where smaller droplets may never reach the target site. Our job as applicators is to find the happy medium, the point between the larger droplets and the smaller droplets, to get the best efficacy and mitigate off-target movement. This is an example of how droplet size is categorized. The majority of nozzles used can be classified as producing very fine, red, fine, orange, medium, yellow, coarse, blue, very coarse, green, and extremely coarse, white. Nozzle suppliers such as T-Jet make it easy for you to distinguish droplet sizes with a color coding system. Here, the yellow M indicates medium-sized droplets, and blue indicates coarse-sized droplets. The chart shows what nozzle type, size, and pressure correspond to the proper droplet class. Some labels specify the droplet size class you must use. This table shows the impact of droplet size on drift. Large droplets are heavier and less likely to move off target because they fall to the ground faster than small droplets. Small droplets tend to stay suspended before gravity is able to bring them to the Earth's surface. For example, with a 3-mile-per-hour wind, medium-sized particles can move at about 30 feet from the intended target area. Avoid fine or very fine droplets below 150 microns because they can move much farther. You can mitigate drift by managing droplet size.
Another thing that you can do is tip selection, the kind of tips that you pick out. Different tips do different things. Insecticides require a certain kind of tip, typically hollow cones, sometimes flat fans. Most herbicides are all flat fans. The biggest issue is the size of a droplet that they make.
Proper nozzle selection is something that is within the applicator's control. Droplet size can also have an impact on pest control. Applicators need to match the nozzle type and size to the type of application. These include type of pesticide, time of application, operating pressure, and the location of sensitive areas near the application site. Technology has advanced drastically over time and has made available an array of nozzle tips that produce drift mitigating droplets. Some pesticide labels give specific nozzle requirements. Let's take a closer look at the patterns made by a couple of different nozzle types. XR11002 will give the most drift. This is an example of a nozzle that creates fine droplets that have more potential for drift. TTI 11004 red dicamba approved nozzle. This is an example of a nozzle that creates ultra coarse droplets and is an option for use when drift is a concern. Be sure to check that your equipment is in good working order prior, during, and after applications. Always be sure to check and make sure that the screens are clean and that nozzles are working properly. Nozzles will need to be replaced when they are not operating based on minimum standards. Be sure to check your spray pattern prior to and during applications. It is critical to properly clean the equipment after applications. Properly cleaning equipment will help ensure that nozzles and other parts of the equipment are working up to specifications. Adjuvants, or tank additives, are sometimes incorporated to help reducing drift potential of a spray solution. Drift reduction agents can affect droplet size, stability, and reduce unwanted movement of pesticides. However, it is important to note that pesticides themselves can also have an effect on droplet size. It is important to read the pesticide and adjuvant labels carefully to ensure compatibility when mixing and applying products. Other equipment that can help mitigate drift are boom shields. Use shields that cover partially or fully the distance between the target and the nozzles. There are companies manufacturing and selling such attachments to the boom. Shields prevent small droplets from moving away from the immediate application area. This, however, may not be practical in all situations. Equipment and application factors such as equipment speed, distance from the target, or boom height, nozzle type, nozzle size, and nozzle pressure are critical in mitigating drift. So to recap, spray when the weather conditions are conducive. Spray when wind speeds are between 3 and 10 miles per hour. Don't spray when a temperature inversion exists. Properly set up your equipment. Travel speed no greater than what is recommended on the product label, nozzle catalogs, and equipment manuals. Correct boom height and correct nozzle choice for the job.
So boom height, 24 inches. Ground speed, where you can control it to where you're making sure you're staying above target. Nothing greater than 10 miles an hour wind speed at application. And then watch your temperature inversions.
High spray pressure or inappropriate spray nozzles can make more of the fine droplets, which are the most drift prone. Applicators are encouraged to include as many strategies as possible into their daily application routine to mitigate drift. One item alone may not prove successful. Many have thought the addition of drift control additives alone would be the cure-all. Technological advancements are occurring that are showing promise in reducing drift. Be open-minded regarding adoption, even though many are coming with hefty price tags. The price of a drift claim as a comparison should always be kept in mind. We can't eliminate drift entirely, but by using good management and adopting spray practices with drift mitigation in mind, we can continue to improve drift mitigation. Drift can be managed successfully with the right knowledge of the equipment and the factors influencing drift. Every application must be balanced between managing drift and maintaining effective crop protection. Mitigating spray drift is in the best interest of everyone. Do your part to keep your applications on target.